Hello, physics. This is a very interesting question. Question says that the speed of light of a light experiment. A Danish scientist Romer in 1619 he has performed the experiment. He observed that Io, the moon of the Jupiter, the mean time interval between the successive eclipse of Io between Jupiter is equal to the period of the orbit, which is a 42 hour 28 minute and 42 seconds. However, the same month in region A, the period is of the IO is greater, and in some region the period is uh, uh, lesser. So, is it increased or decreased? Sketch the diagram of indicating the region A and B. So, it is this is Earth and this is its orbit, and it is moving in this direction in anti-clockwise. So, this is A, and this is B. So sometimes is increasing and sometimes is decreasing. Next question is that if the radius of the Earth is this radius of the Earth is 1.5 into 10 power 19 meter, and the period is 365 days. If the variation of the period is 15 second longer or shorter than the mean, what does this give the speed of light? So the speed of the Earth is 29,900 meter per second. The time the eclipse is equal to 42 hour 28 minute and 42 seconds. The distance traveled by the Earth is SS is equal to V into T, which is equal to 4.57 10 power 9. So light has traveled extra distance in 15 seconds. So extra distance divided by 15 is equal to 3.88 meter per second. This is the speed of light. This is a very excellent experiment. Sketch the graph of the axis showing variation this period of Io on Earth. So this is the mean variation where there's no and then it is going up and down and the different time of the year. So this is question number 11. Like question number 12 is the resistance circuit. So what is the ratio of R1 and R2? These are two resistance, same resistance, so that the power dissipated in R1 is equal to the power dissipated into R2. So this is R1 and R2. So the current in R1 is double, is half. So this is here R1 is half of the R2 because it's divided. So two cars and then is a double one cars if this is a circuit. So the equal power is equal to I square R is equal to I over 2 whole square R. So R1 I cancel. So R1 is equal to R square by 4. So R1, R2 is 1 over 4. So the current is half and the resistance is 4 times. Full scale deflection FSD, when the current of the 2 milliamp flow through the coil which has a resistance of 5 ohm. To measure the current of the zero point 0.2 ohm ampere, the circuit requires low resistance in parallel, so not all the current flows through the coil. What value of the resistor is needed? So this is the ammeter, and this is the resistor. This is the point. This is a 2 milliamp is flowing in a 5 ohm. So V is equal to IR. So I is equal to 2 milliohm amp multiplied by 5. So voltage across this one is 5 millivolt. So for zero point 0.2 amp, so for 2 amp is 2000 milliampere. So 2000 take away 2, which is this 198 milliamp and 10 millivolt. So the resistance is a 10 milli divided by 198. It is equal to zero point 0, very small resistance, 0.0505 or zero point 0.05 ohm. The next question is if a 2 milliamp and 5 ohm resistance is a moving coil meter, is used as a voltmeter instead of to measure to 4.0 full-scale deflection, what value in series of the resistor would be required? So ammeter, resistors, full-scale deflection, which is voltage, V is equal to IR, I is equal to 2 milliamp multiplied by 5, which is 10 millivolt. So resistor in series, so that will be 4 volt minus 10 millivolt divided by full current, which is 2 milliamp. So this is equal to nearly 2 kilo ohm. So this will be very large resistor in the series. This is another question. This is a high gain amplifier is one which the difference of the small input voltage between the input load is multiplied by the large factor and polarity is inverted from plus to minus 10 to the power 6. V output is minus 10 to the power 6 V in. This high gain is not useful. So this is C, D, E, F outputs. So V in and V out. This is grounded. So V output is 2.0 volt. So mark the potential of the terminal. So C, D, E, F at C. So there are four options. Oh no, there will be four. So C is 2 micro because and D is a 0 volt because this one, F is a 0 volt. So this is a 2 and this is 10 to the power 6 time. So with the minus sign, a negative inverted. So inverted, this is negative. So this is a 2, this will be minus. This is a 2 uh, minus 10 to the power and this will be 10 to the power minus 6 and this will be 10 to the power minus 6 multiplied, which is 2. Next question is R1 and R2 are given like this one. This is the same gain circuit. So R1 and R2 are connected to the amplifier. No current flow to the terminal C. So terminal C, this one, terminal C on the amplifier V. P potential at the C is small. V output over 10 to the power 6 is equal to Vp because of this one, this 10 to the power 6. So write down the current through R1 through R1 and R2 in terms of polarities across them. What amplification out to the fluid? Uh, one what approximation to find V out over Vn? What is the gain? So current in R1 is V in over V out raised power divided by this one, 10 power 6 divided by R1. So this voltage, so and V R2 is that will be negative. V out multiplied by 10 to the power 6 minus V out over R2. So the current at C is IR is equal to IR R2. There's no current. So approximation is V out over V raised to 10 to the power 6 is so small compared to the V out and V in. So V in is R1, V out is R2, out over in, which is gain, which is R2 over R1. So the ratio of the resistor R1 and R2 give us the gain. So that is the